out parallel and perpendicular lines and having them go through points. So if I give you an equation like y equals 4/5 x plus 3, and I want you to go through the coordinate point -5, 2, and then I'm going to ask you to draw a line that is perpendicular to it. Or I could ask you to go parallel through it. So we'll look at both. Okay, so if I were to be perpendicular to this line, what would I do?
You get the opposite reciprocal of the slope of that line.
Okay, so I know the slope of this line is going to be -5/4. Good, so we'll make it negative and flip it. And then how would I find out the equation of that line?
Put in, it's going to be y equals -5/4 x. Plug in 2 for y.
Okay, so we're going to plug in this coordinate point, which is an x comma y coordinate point. We're going to plug it in for x and y. So 2 is going to equal -5/4, which is my slope, times x, which is -5, plus our unknown, which is our new y-intercept. And now we only have a single variable, so we can go solve for it. This is going to turn into 25/4. Okay, equals 2, which how many fourths is 2? 8/4. Okay, plus b. I chose to do that so that I had common denominators so that the fractions would work out. Now we can subtract it. So our b is going to be -17/4. Okay, kind of ugly, but it works. And our final equation would be y equals, our new m is -5/4 x plus b, which our new b is -17/4. Okay, anybody got another idea of how to make that easier? Jesse?
You can just put it into
Point slope form.
Yeah.
So that's that y minus y1, which in this case my y1 is 2. My slope is the -5/4 times our quantity x minus x1, which that's -5, so this will be an x plus 5. Okay? Either of those is an acceptable answer. Okay? You do not need to do a whole lot of math with point slope form. Okay? Go ahead and just put that on your cheat sheet so you've got that formula. Y minus y1 equals m times the quantity x minus x1. Okay? If you were to do it parallel. Y minus y1 equals your slope m times the quantity x minus x1. That's point slope form. Hopefully we've seen that a handful of times in the last 4 years. So next equation, what if I asked you to do parallel? What would you do? Same slope. So the easiest way to do this would be point slope form. So we've got y minus 2, stays the same, equals, now our slope is the same, so it's still 4/5 times x minus x1, so plus 5. Boom, I'm done. Okay? Or you could go through the same process we did over here, and we would figure out that 2 equals 4/5 times -5 plus our b. In this case, it works out a little bit nicer because this is just -1, so that would be a -4 now. And so we'll add 4 over, so 6 would be our b in this case. So we end up with y equals 4/5 x plus 6. Okay. So point slope form is totally acceptable, and I would actually encourage that. Okay, next thing we're going to take a look at is distance and midpoints. So if I give you a coordinate grid and a couple of points on it, let's do one at -10, 4. And we'll do another one over at 2, -1. How do I find the distance between these 2 points?
Distance formula.
We need the distance formula, basically. Anybody remember the easiest way to remember the distance formula? What does it create? The right triangle, so we use
Mine's different than his.
Pythagorean theorem, basically. Okay, there's my A, there's my B, there's my
I think he
C.
wrote down the same.
So I know that A squared, which in this case is my difference in x's,
Yeah, this is standard.
A squared plus B squared,
Standard slope.
my change in my y's, is going to equal my C squared, which in this case we're going to call distance. And instead of distance squared, we're going to take the square root of both sides, so that's how they come up with the distance formula. Okay, just Pythagorean theorem. So we can plug in these points. We end up with negative 10 minus 2 squared plus 4 minus, that's a negative 1, sorry. Minus a negative 1 is like plus a positive. We'll end up with negative 12 squared plus 5 squared, which gives us 144 plus 25, which is square root of 169, which happens to be a nice number, 13. So my distance is 13 in this case. If it's not a nice number, just leave it in radical form. How about midpoint? How do we find the middle of something? Midpoint formula, right? Okay, I want to figure out where that is. Okay, if I've got stuff, I want to find the middle of it. We want to find the middle, which we find the middle of stuff by finding the average, right?
C.
So the average of stuff. So we're just going to say, okay, average of my x's. Okay, so we'll add them together, divide by 2, find the average of the x's. Comma, we're going to find the average of our y's. So we'll add those together and divide by 2. Okay, in this particular case, we'll have negative 10 plus 2 over 2, which is 4. Negative 4. And our y's will be 4 plus a negative 1, which will be 3 halves. So my midpoint will be at negative 4, 3 halves. Okay. So there's our distance and midpoint formulas. Next thing we're going to take a look at is we're to describe the behaviors of graphs.
Well, will you go back real fast? I just want to.
Next thing we'll look at is we're going to describe the behaviors of graphs.
Thank you.
So if I give you something, let's see, 3, 5, 2, 4, 6, and 4, and 5. Okay, let's say that's my function. So based on this function, I will ask you a handful of things. Things that are possible to be asked is domain, range, where it increases, where it decreases, where it's above 0 or equal to 0, where it's below 0, And I could ask you about the local minimums. And the local maximums. Okay. So those are the possibilities that I could ask you. In this case, my domain is all of our x's. So what's my domain? All real numbers. This will be an interval notation as well. Okay. I will accept all real numbers without the infinity and infinitive in them. So interval notation. Okay. The range would be all of our y values. It's less than 6. It's less than or equal to 6. So we know that we've got from negative infinity to 6 square bracket. Okay, again, this can be given as negative infinity to infinity also. Okay. Where it's increasing, one of the ways I like to look at this is as I'm reading left to right. Just draw little arrows. So as I go left to right, this is going up. So this is clearly increasing. Once I hit this point, it's starting to go down. Then it's going to go up again. And it goes down. Okay? So little arrows will sometimes go a long ways to help you out with this. So as I'm increasing, that's when my x values are negative infinity all the way up to negative 3, because we're looking at the x values here. Okay? Unioned with 0 to 4. Okay. Yes, Charles. The what?
What is like a unit called? No, like the unit of this.
Oh, this was the chapter 2 stuff, and looking at identifying features of a function or something like this. But it was the chapter 2 stuff. Yes.
Use square brackets.
So I'm not going to use square brackets here because when I'm at the top, this is a good question. When I'm at the top or bottom, I'm not really increasing or decreasing. My slope is 0. And so we're going to use curved brackets because at those endpoints, it's actually not increasing or decreasing. So decreasing then would be from negative 3 to 0. Unioned with 4 to infinity. Okay? And then we can look at where am I above 0. My x values are okay, so I'm above 0 from negative 5 to 5. I have an equal sign here, so do I use square brackets or rounded? Square, because we'll include both those endpoints. And then where am I below 0? The 2 tails, so from negative infinity up to negative 5 without including it, because there's no equal sign, so we don't include it. Unioned with positive 5 to infinity. Okay, so this is that chapter 2 stuff. If you want extra practice on that, go back, look at your chapter 2 test and those types of things. That's what I would look at. Max and mins. Okay, we're just looking at locals, okay? That's your peaks and your valleys, and I'll even note that on your test for you. So, yes?
You have square brackets on the bottom one. No, the one down.
These ones aren't square. These should be rounded. Part of it's because my pen is skipping around because of the diagonals. So those are round because there's no equal sign. If there's an equal sign there, we'll include it so it'll be more square-like. Yeah. Okay, so the local minimum. Where's my local minimum? Yes?
0, 2.
0, 2. So there's my local minimum right there. So this coordinate point. And that's my only local minimum. And then my maximums would be at -3, 4, and 4, 6. Okay, so those are my 2 peaks. And I have 1 valley. Those are actual coordinate points. Okay, so this is the describing a graph type stuff. Next thing that we're going to take a look at, I believe in the order of the test, is going to be simplifying stuff. So you're going to have things like 3 minus 2i or 5 minus 3i. Why is that not simplified? There's an I in the bottom, right? What is I defined as? The square root of -1. We don't like radicals in the denominator, so we need to rationalize the denominator. How do you do that? Good. We're going to multiply by the complex conjugate. That's the vocab word for it. What that means is you're taking that inside symbol and you're flipping it. Anybody know why we do that?
Cancels the bottom side.
We're multiplying by a disguised 1, so it won't change anything. Good. And it eliminates the middle term of i's because we have that difference of squares. So hopefully we start to recognize that pattern. Okay, and then we'll create an I squared situation. What is I squared? Just -1, so we no longer have radicals on the bottom. So that's what we're looking for and why we do it. Okay, so this is going to equal, we'll just distribute. So you end up with 15 plus 9i minus 10i minus 6i squared all over 25 plus 15i minus 15i minus 9i squared. Okay, so as expected, our i's will cancel, so that's good news. That's how you know you've done it right and you did the complex conjugate correctly. Your I should disappear. And so up top, let's substitute this in. Okay, so this is just +6, so 15 plus 6 is going to be 21. Collect our like terms, so 9i minus 10 is going to be minus 1i. Over 25, again, we're going to substitute our I squared in here. So we're going to end up with just 25 plus 9, which is 34. Now in standard form, I will tell you to please put your answer in standard form, which is A plus BI.
Yeah, but there's a negative in front of it, so it makes it plus.
So what ends up happening here is this will look like 21 over 34. If it's reducible, reduce it. If not, just leave it. Minus 1 over 34i. So we clearly know what our A and B are. Because it's just one I.
-1i.
Yep. Yep. All right, so that'll be simplifying complex division of complex numbers.
What is the rest of the i's? It's like I negative I.
I cubed is -I, and I to the 4th is +1. And then it repeats that cycle. So then the other thing you'll look at is the square root of -72. 72. Something like that. Yes.
So, I cubed -1 times the square root of -1.
Correct. Or -I.
What was that?
That's essentially, yeah. So square root of -72, what am I trying to do here? Good, so we can always pull out the square root of -1. That's the I piece of it. That's our definition. Okay, then we can pull out other stuff. If you want, you can try to find the biggest one right away, which in this case would be 36 times 2. Why did I choose 36? Because it's the perfect square. So this turns into 6i radical 2. You could also have broken it down into 9 and 8, and then you would have had to break down 8 into 4 and 2, and you would have gotten to the exact same spot. All right, next one is going to be the one-story problem that we've got. Okay, it's going to be a profit equation. Okay, so profit equation, I will give you a quadratic profit curve. I'm going to ask you to find where we're profitable and what our maximum profit is. And so you'll have something like negative 1/4 x squared plus 16x minus 120. Okay, so you'll have some equation like that that'll represent your profit. Again, the questions that'll be asked is when are we profitable? Okay, we'll ask how many units to sell to maximize profit. And then we'll ask what is the max profit. Okay, so there'll be 3 parts to this. So, first piece is to recognize how do we figure out when we're profitable? What do we need to know in order to know when we're profitable? So we need to know the break-even. And what is our break-even point? 0. It's the x-intercepts. So I have no profit as our break-evens. So if we plugged in 0 up there for this function, okay, now we can use the quadratic formula to find the x-intercepts. So x is going to equal, your quadratic formula, if you don't have it, is negative b plus or minus the square root of b squared minus 4ac all over 2a. When I do my quadratic formula, I like to actually split it into 2 fractions because negative b over 2a tells me something. Anybody remember what that is?
Isn't that like a vertex?
It's the vertex. Good. So the vertex will help us figure out where we make the most profit. So it'll find us the max or the min. In this case, because it's a downward facing parabola, it'll be a maximum. Okay, so as we work through the rest of this formula, we'll see that 32 plus or minus the square root of 136 over negative 1/2. Okay, which doesn't necessarily matter if it's a negative or not, since it's plus or minus. So it actually kind of disappears, and dividing by 1/2 is the same as multiplying by 2. So this is the same as 2 radical 136. And with the decimal approximation, that means that we're going to plus or minus, I believe it ends up being like 11.3. I think, anyway, with a calculator, I can't remember from my previous class, but I think it's 11.3. Maybe.
Wait, what is?
No, that's not right. Because it's going to be 11.3 times 2, so it's like 23.3. Thank you.
Freeberg, shouldn't the vertex be 8?
No.
Because it's 16.
Divided by half. It's like multiplying by 2. So my 2 break-even points are at 32 minus 23.3 is 8.7. And at 55.3. So how many things do I need to make a profit? So I'm going to the nearest like actual units sold. How many do I need to make a profit? 9. Okay? But no more than 55. Okay, so we are profitable between 9 and 55. How many should I make to maximize my profit? 32. That's where this vertex comes in. That's a nice piece, that negative b over 2a. So I should make 32 to maximize profit. How do I find my actual max profit?
Plug it in.
Plug it back in. So we're going to throw in 32 for our X value. And when we do that, I believe it spits out 136. Whether that's thousands or just actual dollars or whatever. So maybe we're making cars or something and we can make 9 to break even and cover our operating costs, but people start charging overtime and stuff, so it gets more expensive. So we got to make sure we make less than 55. Ideally, sell 32 cars and make 136,000 bucks a month or something. Okay. So that could be a situation you would see. The backside of the test is basically what we've already done, which is the finding the zeros of polynomials, and then finding your horizontal asymptotes and stuff of rational functions. So next one you'll see is given a function like x cubed minus 3x squared minus 10x plus 24. I want to go find the zeros of that. What do we like checking first? Is 1 going to work? Negative 13 plus 25. Nope, that won't work. Okay, then we like to check negative 1. So that would be negative 1 plus 3 is 2. Plus 10 is 12. Plus 24 is 36. That won't work. Okay? So let's go check 2. Okay, that's a factor of 24, so that's a possibility. Let me plug in 2, 1, negative 3, negative 10, 24. Okay, the most common error I saw in our last test is when you do synthetic division, make sure you drop this first one straight down. Don't do any math to it. Okay, a handful of people were trying to do operations here that it made everything go crazy. Negative 2, negative 12. 4. Okay. And again, we're multiplying here so that we can add the column, multiply, add, multiply, add. Okay. When we find a 0, we found our 0 to the function. This tells me that x minus 2 is a factor. This is the same as x squared minus x minus 12. So what are my other two factors? Negative 4. So x minus 4, x plus 3. Which tells me the zeros of this function are x equals 2, 4, and negative 3. We can find our zeros. Okay. So you'll have to find the zeros. Then I'll ask you based on based on this function, what's your end behavior? Okay. And just so you know the way it will be asked, I will ask you left side. Up or down. And I will ask you right side, up or down. And you will have to circle one of them. Okay, so we know that it's down to up. Okay, because it's an odd degree and it's positive, so it behaves like our typical cubic function. So we've got that down to up behavior. All right, last question on the test is going to be the rational functions.
Wait, so it goes down to up.
I'll give you something like this, 4x squared plus 8x plus 4, x squared minus 4. Okay. And then I will ask you to find the vertical asymptotes. The horizontal asymptote. If it crosses it, and where? Okay, so this is kind of the one new piece. If it crosses, horizontal asymptote, and where? And then the x-intercepts. Okay, so which one do you want to answer first, or do you want to do something to the formula, the function, before we do any of this? Factor it down first. I like that idea. Okay, so I can pull out a 4, which will leave us with x squared plus 2x plus 1. That actually can factor down even further. So on top, we'll actually end up with 4 times x plus 1, that quantity squared, over, on the bottom we end up with x minus 2 and x plus 2. It's our difference of squares. Now we have a function that's going to be much easier to answer these questions. What's my vertical asymptotes? The zeros of the denominators, so it'll be at x equals 2 and at x equals negative 2. What's our horizontal asymptote? It's at 4. Good. So if I look at my dominant terms up here, I can ignore the non-significant stuff. So you have 4x squared over x squared. If the x squareds cancel each other, we're left approaching 4. So this will approach the line y equals 4. How do I know if I cross that asymptote? We plug it in. So you're going to take 4 and plug it into this equation. So you end up with 4 equals that equation. Okay? And so when you do that, multiply by the denominator. So 4x squared minus 16 will equal 4x squared. Let's see if I can squeeze this in there. Plus 8x plus 4. Okay, and then subtract 4x from both sides. Those will cancel. Subtract 4, so you get negative 20 equals 8x. And then divide by 8, so we get negative 5 halves equals x. Okay, so we know that, yes, it will cross at x equals negative 5 halves. How would I know if it doesn't cross? No solution. The x's will disappear entirely, typically. Okay? Or you'll get the square root of a negative number or something weird like that. So it won't be a nice number. And then lastly, where are my x-intercepts at? Negative 1. And it has a multiplicity of 2. Okay? I will not ask you to graph this, but if you want to for fun, maybe I should put it in there as a bonus. Okay?
Yes.
What you would do is you have your asymptotes at 2 and negative 2, and y equals 1, or y equals 4, sorry. Y equals 4. And then we know we have intercepts at negative 1 with multiplicity of 2, so it'll bounce. So I'm going to be somewhere up in that category, because I don't have an intercept. I know based on my multiplicity of the asymptotes, we should start down here. It's going to come up at some point and bounce and disappear back down. And then I know that it's got to be up here for 2 reasons. One, I don't have, one, I don't have asymptotes. Sorry, asymptotes. I don't have an x-intercept down here. But I do know I crossed the asymptote at negative 5 halves, which is actually at this coordinate point. So it's going to be up here based on the multiplicity. But it'll go through the asymptote and then level back out at it. So, anyways, that could be a bonus piece. Maybe I'll throw that on there. But that is going to be your test. Please prepare for that.